Enter digi. To alleviate stress while note-taking in class, digi is a simple writing capture system that attaches onto a marker, pen, or piece of chalk that communicates wirelessly with the stationary receiver in order to track live writing and automatically digitize notes. Now, you have exactly what the lecturer has, and you can pay attention and focus on the material in class.
The solution has two components, relative movement detection and absolute position detection. These moments can be gathered via an optical sensor along with positioning information from Bluetooth 5.1, which are then processed using software to get digitized notes. These digitized notes are then streamed to users' devices in real time. Users will also have the option to save the stream to their local device, annotate and customize the canvas, and convert it to other document formats according to their personal preferences.
So the technical details of this project are as follows. This clip-on device will have an optical motion sensor similar to that in an optical mouse and a Bluetooth 5.1 transmitter. We will also have 4 Bluetooth 4.1 receiver beacons on each corner of the writing surface. By employing an array of antenna, we get the angle of arrival on each of the receiver beacon. This will enable us to get the absolute position of the clip-on device on the writing surface. The clip-on device will then transmit relative positioning data from optical sensor to the beacon. Combining the absolute and relative positioning of the mobile clip-on device helps us follow the clip-on device precisely and capture the writer's movements. We plan to either use a Raspberry Pi or a computer to build this virtual canvas. Then we plan to live stream these changes to users' device wirelessly.
As you can see here, we have a Python script running in the terminal that's reading the cursor's position data from the sensor's registers and printing them. We also have a canvas up where the pen strokes are accurately recorded. As soon as the IR sensor is close enough to the writing surface, it detects the relative position data and sends it to the Raspberry Pi, which has a wireless USB receiver. We then decode the data into exact relative coordinates and mark it onto the canvas.
In the spring, we plan to comprehensively test out the Bluetooth 5.1, but also LiDARs and ultrasonic sensors. From this, we intend to choose the one that gives us the best absolute positioning accuracy at a reasonable price. Then we then plan to build a software component that uses the marker location data to get digitized notes and distribute them in real time. We will then test the system exhaustively to ensure optimal product quality.